Here's the periodic table. It's a way of organising all the 118 known elements in our universe.
But what are the elements, and what are some of the ways we use them in our everyday lives?
To explain that, we're going to go through every single element one by one. Element number 1 is hydrogen, and its symbol is H. It's a non-metal, and its atoms contain 1 proton, 1 electron, and 0 neutrons. Hydrogen was discovered by Henry Cavendish in 1766 and is named after Idor Yeneme, the Greek for I create water. It's the lightest and most abundant element in the universe and is used in rocket fuel.
Element number 2 is helium, and its symbol is He. It's a noble gas, and its atoms contain 2 protons, 2 electrons, and 2 neutrons. Helium was discovered by Pierre Janssen and Norman Lockyer in 1868 and is named after Ilios, the Greek word for sun. It's used to fill balloons to make them float because it's lighter than air, but also cools down the magnets in MRI scanners.
Element number 3 is lithium, and its symbol is Li. It's an alkali metal, and its atoms contain 3 protons, 3 electrons, and 4 neutrons. Lithium was discovered by Johann August Arfvedson in 1817 and is named after lithos, the Greek word for stone. It's used in batteries for things like electric vehicles, mobile phones, tablets, and laptops.
Element number 4 is beryllium, and its symbol is Be. It's an alkaline earth metal, and its atoms contain 4 protons, 4 electrons, and 5 neutrons. Beryllium was discovered by Louis-Nicolas Vauquelin in 1798 and is named after the mineral beryl. Because it's lightweight and can remain stable in space for a long time, beryllium is used to make mirrors for satellites.
Element number 5 is boron, and its symbol is B. It's a semi-metal, and its atoms contain 5 protons, 5 electrons, and 6 neutrons. Boron was discovered by Joseph Louis Gay-Lussac and Louis-Jacques Thénard in 1808 and is named after borac, the Arabic word for borax. It's used in fiberglass, insecticides, and even cosmetics.
Element number 6 is carbon, and its symbol is C. It's a non-metal, and its atoms contain 6 protons, 6 electrons, and 6 neutrons. Carbon was discovered by the Egyptians and Sumerians in around 3750 BCE and is named after carbo, the Latin word for charcoal. You can easily find some carbon in the form of graphite at the end of a pencil, and under high temperatures and pressures, that graphite will turn into diamond.
Element number 7 is nitrogen, and its symbol is N. It's a non-metal, and its atoms contain 7 protons, 7 electrons, and 7 neutrons. Nitrogen was discovered by Daniel Rutherford in 1772 and is named after Nitron Yeneme, the Greek for I create niter, which is a mineral. As a gas, nitrogen is used in things like explosives, and as a liquid, it's used by scientists when conducting low-temperature experiments.
Element number 8 is oxygen, and its symbol is O. It's a non-metal, and its atoms contain 8 protons, 8 electrons, and 8 neutrons. Oxygen was discovered by Carl Wilhelm Scheele in 1771 and is named after oxy-yenome, the Greek for I create acid. Plants and animals need to breathe oxygen to survive, but it can also be stored in canisters to help scuba divers breathe underwater or astronauts breathe in space.
Element number 9 is fluorine, and its symbol is F. It's a halogen, and its atoms contain 9 protons, 9 electrons, and 10 neutrons. Fluorine was discovered by André-Marie Ampère in 1810 and is named after fluor, the Latin word for flowing. Fluorine is used in toothpastes and even air conditioning.
Element number 10 is neon, and its symbol is Ne. It's a noble gas, and its atoms contain 10 protons, 10 electrons, and 10 neutrons. Neon was discovered by William Ramsay and Maurice Travers in 1898 and is named after neos, the Greek word for new. You've probably heard of neon signs, but lighting up signs using just neon only produces a small amount of colours. Other coloured signs need different elements, even though they're often still called neon signs.
Element number 11 is sodium, and its symbol is Na. It's an alkali metal, and its atoms contain 11 protons, 11 electrons, and 12 neutrons. Sodium was discovered by Humphrey Davy in 1807. Its name comes from the word soda, and its symbol comes from natrium, the Latin word for soda. It can be combined with chlorine to create table salt, but it's also used for much bigger things, like cooling nuclear reactors.
Element 12 is magnesium, and its symbol is Mg. It's an alkaline earth metal, and its atoms contain 12 protons, 12 electrons, and 12 neutrons. Magnesium was discovered by Joseph Black in 1755 and is named after Magnesia, a now disbanded division of Greece. Because it's both strong and light, magnesium is often mixed with other metals to make parts for cars, aircraft, and missiles.
Element number 13 is aluminium, and its symbol is Al. It's a basic metal, and its atoms contain 13 protons, 13 electrons, and 14 neutrons. Aluminium was discovered by Hans Christian Ørsted in 1824 and is named after alum, the Latin for bitter salt. Because it's very cheap, aluminium is used in thousands of products, such as drinks cans, kitchen foil, and cooking utensils.
Element 14 is silicon, and its symbol is Si. It's a semi-metal, and its atoms contain 14 protons, 14 electrons, and 14 neutrons. Silicon was discovered by Jöns Jakob Berzelius in 1823 and is named after silex, the Latin word for the stone flint. It's a semiconductor which revolutionized computer chips in the 20th and 21st century, leading to names like the Silicon Age and even Silicon Valley in California.
Element number 15 is phosphorus, and its symbol is P. It's a non-metal, and its atoms contain 15 protons, 15 electrons, and 16 neutrons. Phosphorus was discovered by Hennig Brand in 1669 and is named after the Greek for light bearer. It's used in fertilizers, and you can also find it in the red strip on the side of a matchbox.
Element number 16 is sulfur, and its symbol is S. It's a non-metal, and its atoms contain 16 protons, 16 electrons, and 16 neutrons. Sulfur was discovered in the Middle East before 2000 BCE, and it's named after a Latin word meaning to burn. It's used in things like skin treatments and furniture decoration, but most of it is converted into sulfuric acid.
Element number 17 is chlorine, and its symbol is Cl. It's a halogen, and its atoms contain 17 protons, 17 electrons, and 18 neutrons. Chlorine was discovered by Carl Wilhelm Scheele in 1774 and is named after chloros, the Greek for pale green. Because it kills bacteria and germs, chlorine is used to keep swimming pools and drinking water clean and safe.
Element 18 is argon, and its symbol is Ar. It's a noble gas, and its atoms contain 18 protons, 18 electrons, and 22 neutrons. Argon was discovered by John William Strutt and William Ramsay in 1894 and is named after the Greek word meaning inactive. It's used in things like welding, incandescent light bulbs, and double-glazed windows. Argon is also used in neon signs and actually produces more colours than neon itself.
Element number 19 is potassium, and its symbol is K. It's an alkali metal, and its atoms contain 19 protons, 19 electrons, and 20 neutrons. Potassium was discovered by Humphrey Davy in 1807. It's named after the word potash, and its symbol comes from kalium, the Latin name for potassium. It's vital for many processes in the human body, but it's also used for things like inks, dyes, and even fireworks.
Element number 20 is calcium, and its symbol is Ca. It's an alkaline earth metal, and its atoms contain 20 protons, 20 electrons, and 20 neutrons. Calcium was discovered by Humphrey Davy in 1808 and is named after calix, the Latin word for the mineral lime. It's part of a compound that keeps our bones and teeth strong and is also found in rocks and minerals on Earth.
Element number 21 is scandium, and its symbol is Sc. It's a transition metal, and its atoms contain 21 protons, 21 electrons, and 24 neutrons. Scandium was discovered by Lars Friedrich Nielsen in 1879 and is named after the region of Scandinavia. It's used in lights designed to replicate the sunlight for things like TV and film production.
Element number 22 is titanium, and its symbol is Ti. It's a transition metal, and its atoms contain 22 protons, 22 electrons, and 26 neutrons. Titanium was discovered by William Gregor in 1791 and is named after the Titans, characters from ancient Greek mythology. It's biocompatible, which means the human body won't try and get rid of it, so it's used for things like hip replacements and dental implants.
Element number 23 is vanadium, and its symbol is V. It's a transition metal, and its atoms contain 23 protons, 23 electrons, and 28 neutrons. Vanadium was discovered by Niels Gabriel Säfström in 1830 and is named after Vanadis, one of the names of the Norse goddess Freya. It's used to improve the strength of steel for things like gears and bicycle frames.
Element number 24 is chromium, and its symbol is Cr. It's a transition metal, and its atoms contain 24 protons, 24 electrons, and 28 neutrons. Chromium was discovered by Louis-Nicolas Vauquelin in 1794, and it's named after chroma, the Greek word for colour. It's mixed with iron to make stainless steel, which is strong and doesn't rust.
Element number 25 is manganese, and its symbol is Mn. It's a transition metal, and its atoms contain 25 protons, 25 electrons, and 30 neutrons. Manganese was discovered by Carl Wilhelm Scheele in 1774 and is named after Magnesia, a now disbanded division of Greece. It's used in certain United States $1 coins to ensure that they have the electromagnetic properties needed to work with vending machines.
Element number 26 is iron, and its symbol is Fe. It's a transition metal, and its atoms contain 26 protons, 26 electrons, and 30 neutrons. Iron was discovered in the Middle East before 5000 BCE, and its symbol comes from ferrum, the Latin name for iron. It's an important part of the blood in our bodies, and thousands of years ago it was used extensively to make tools and weapons during the so-called Iron Age.
Element number 27 is cobalt, and its symbol is Co. It's a transition metal, and its atoms contain 27 protons, 27 electrons, and 32 neutrons. Cobalt was discovered by Georg Brandt in 1735 and is named after Kobold, the German word for goblin, due to superstitious beliefs among cobalt miners. It's been used for centuries to produce blue colours in paint, pottery, and glass.
Element 28 is nickel, and its symbol is Ni. It's a transition metal, and its atoms contain 28 protons, 28 electrons, and 31 neutrons. Nickel was discovered by Axel Friedrich Grunsted in 1751 and is named after Kupfernickel, the German for devil's copper, due to superstitious beliefs among nickel miners. Nickel is used to make rechargeable batteries, coins, and even guitar strings.
Element number 29 is copper, and its symbol is Cu. It's a transition metal, and its atoms contain 29 protons, 29 electrons, and 35 neutrons. Copper was discovered in the Middle East in 9000 BCE. Both its name and symbol come from Cuprum, the Latin name for the country Cyprus, where a lot of it was mined. Because it's very good at conducting electricity, copper has been used extensively in wiring, for power cables, telephone cables, and other electronics.
Element number 30 is zinc, and its symbol is Zn. It's a transition metal, and its atoms contain 30 protons, 30 electrons, and 35 neutrons. Zinc was discovered by Indian scientists before 1000 BCE, and its name comes from the German for prongs, describing its spiky crystals. It's been mixed with copper to create brass since prehistory and is vital for many aspects of the human body, like DNA.
Element number 31 is gallium, and its symbol is Ga. It's a basic metal, and its atoms contain 31 protons, 31 electrons, and 39 neutrons. Gallium was discovered by Paul-Émile Lecoq de Beauxbatons in 1875, and is named after Gallia, the Latin name for ancient France. It's used extensively in semiconductors for things like mobile phones, LEDs, and solar panels. Gallium has a relatively low melting point, which means a solid block of it would melt in your hand.
Element number 32 is germanium, and its symbol is Ge. It's a semi-metal, and its atoms contain 32 protons, 32 electrons, and 41 neutrons. Germanium was discovered by Clemens Winkler in 1886 and was named after his home country of Germany. It has certain properties that make it ideal for use in optical devices like camera lenses and microscopes.
Element number 33 is arsenic, and its symbol is As. It's a semi-metal, and its atoms contain 33 protons, 33 electrons, and 42 neutrons. Arsenic was discovered by Arabic alchemists before 1815 CE, and is named after arsenikon, the Greek word for the yellow pigment orpiment. Although it's commonly mixed with lead to make things like car batteries, arsenic can be toxic and is very dangerous to handle.
Element number 34 is selenium, and its symbol is Se. It's a non-metal, and its atoms contain 34 protons, 34 electrons, and 45 neutrons. Selenium was discovered by Jöns Jakob Berzelius and Johann Gottlieb Gahn in 1817 and is named after Selene, the Greek word for moon. It's used in many industries such as photography, increasing the contrast of black and white prints and making them last longer.
Element number 35 is bromine, and its symbol is Br. It's a halogen, and its atoms contain 35 protons, 35 electrons, and 45 neutrons. Bromine was discovered by Antoine Jérôme Ballard and Carl Jakob Löwich in 1825, and is named after vromos, the Greek for dirt or stench. It's used to make materials less flammable, and even in medicines to reduce seizures in dogs.
Element number 36 is krypton, and its symbol is Kr. It's a noble gas, and its atoms contain 36 protons, 36 electrons, and 48 neutrons. Krypton was discovered by William Ramsay and Maurice Travers in 1898 and is named after kryptos, the Greek word for hidden. It's used to create white light bulbs for photography and fluorescent lights that have a greenish-blue colour.
Element number 37 is rubidium, and its symbol is Rb. It's an alkali metal, and its atoms contain 37 protons, 37 electrons, and 48 neutrons. Rubidium was discovered by Robert Bunsen and Gustav Kirchhoff in 1861, and is named after rubidus, the Latin for deepest red. It's used to measure time very precisely in atomic clocks, and is even used in fireworks to make them purple.
Element number 38 is strontium, and its symbol is Sr. It's an alkaline earth metal, and its atoms contain 38 protons, 38 electrons, and 50 neutrons. Strontium was discovered by William Cruikshank in 1787 and is named after the mineral strontianite. It's used in things like glow-in-the-dark toys, old televisions, and toothpaste for sensitive teeth.
Element number 39 is yttrium, and its symbol is Y. It's a transition metal, and its atoms contain 39 protons, 39 electrons, and 50 neutrons. Yttrium was discovered by Johann Gadelin in 1794, and it's named after Ytterby, the village in Sweden where it was discovered. A radioactive version of it is used to treat various types of cancer, like bone cancer, leukemia, and liver cancer.
Element number 40 is zirconium, and its symbol is Zr. It's a transition metal, and its atoms contain 40 protons, 40 electrons, and 51 neutrons. Zirconium was discovered by Martin Heinrich Klaproth in 1789 and is named after Zarqun, the Arabic for gold-like. It's often used in high-temperature situations such as metal furnaces and jet engines to protect other materials.
Element number 41 is niobium, and its symbol is Nb. It's a transition metal, and its atoms contain 41 protons, 41 electrons, and 52 neutrons. Niobium was discovered by Charles Hatchett in 1801, and is named after Niobe, a character from ancient Greek mythology. Because it causes fewer allergic reactions than most elements, niobium is used in things like jewellery, prosthetic limbs, and even pacemakers.
Element number 42 is molybdenum, and its symbol is Mo. It's a transition metal, and its atoms contain 42 protons, 42 electrons, and 54 neutrons. Molybdenum was discovered by Carl Wilhelm Scheele in 1778 and is named after molybdos, the Greek for lead-like. It's used to increase various properties of steel, and as a powder, molybdenum is even used as a fertilizer for things like cauliflower.
Element number 43 is technetium, and its symbol is Tc. It's a transition metal, and its atoms contain 43 protons, 43 electrons, and 54 neutrons. Technetium was discovered by Emilio Segre and Carlo Perrier in 1937, and is named after technitos, the Greek word for artificial, because it was the first artificially synthesized element. It's used in studying and imaging many parts of the human body, like the brain, lungs, liver, and kidneys.
Element 44 is ruthenium, and its symbol is Ru. It's a transition metal, and its atoms contain 44 protons, 44 electrons, and 57 neutrons. Ruthenium was discovered by Carl Ernst Claus in 1844 and is named after Ruthenia, the Latin name for Russia. It is used in many different ways, from coating the nibs of fountain pens to exposing fingerprints on a surface.
Element number 45 is rhodium, and its symbol is Rh. It's a transition metal, and its atoms contain 45 protons, 45 electrons, and 58 neutrons. Rhodium was discovered by William Hyde Wollaston in 1804, and is named after rhodon, the Greek word for rose. It's one of the most valuable precious metals, and in 1979, Guinness World Records presented singer Paul McCartney with a rhodium-plated disc for being history's all-time best-selling songwriter and recording artist.
Element number 46 is palladium, and its symbol is Pd. It's a transition metal, and its atoms contain 46 protons, 46 electrons, and 60 neutrons. Palladium was discovered by William Hyde Wollaston in 1802 and is named after the asteroid Pallas, which itself comes from a name for the ancient Greek goddess Athena. It's used in things like catalytic converters, which reduce the toxic gases coming from car exhausts.
Element number 47 is silver, and its symbol is Ag. It's a transition metal, and its atoms contain 47 protons, 47 electrons, and 61 neutrons. Silver was discovered before 5000 BCE, and its symbol comes from argentum, the Latin name for silver. It's a precious metal that's been used for jewellery, coins, and silverware for millennia.
Element number 48 is cadmium, and its symbol is Cd. It's a transition metal, and its atoms contain 48 protons, 48 electrons, and 64 neutrons. Cadmium was discovered by Carl Samuel Liebrecht Hermann and Friedrich Strohmeyer in 1817 and is named after Cadmus, a character from ancient Greek mythology. It's used in things like electric batteries, pigments, and coatings.
Element number 49 is indium, and its symbol is In. It's a basic metal, and its atoms contain 49 protons, 49 electrons, and 66 neutrons. Indium was discovered by Ferdinand Reich and Hieronymus Theodor Richter in 1863, and is named after the word indigo. It's used in touchscreens on modern devices as it recognises contact from human skin and can pinpoint its location.
Element 50 is tin, and its symbol is Sn. It's a basic metal, and its atoms contain 50 protons, 50 electrons, and 69 neutrons. Tin was discovered around 3500 BCE, and its symbol comes from stannum, the Latin word for tin. It's mixed with copper to create bronze, an important material thousands of years ago during the so-called Bronze Age. Nowadays, tin is used in many ways, such as fusing multiple pieces of metal together in a process called soldering.
Element number 51 is antimony, and its symbol is Sb. It's a semi-metal, and its atoms contain 51 protons, 51 electrons, and 71 neutrons. Antimony was discovered by Arabic alchemists before 1815 CE. The origin of its name isn't fully understood, but its symbol comes from stebium, the Latin for eye paint, one of antimony's earliest uses. Because it can prevent oxygen from creating bubbles, antimony is used to treat glass for things like television screens.
Element number 52 is tellurium, and its symbol is Te. It's a semi-metal, and its atoms contain 52 protons, 52 electrons, and 76 neutrons. Tellurium was discovered by Franz Josef Müller von Reichenstein in 1782 and is named after Tellus, the Latin name for Earth. Because it has low electronegativity, tellurium is used extensively in solar panels.
Element number 53 is iodine, and its symbol is I. It's a halogen, and its atoms contain 53 protons, 53 electrons, and 74 neutrons. Iodine was discovered by Bernard Courtois in 1811 and is named after Eilthes, the Greek word for violet, the colour of iodine gas. Because it turns blue in the presence of starch, iodine is used in chemical analysis to detect things like fake banknotes printed on starch-based paper.
Element number 54 is xenon, and its symbol is Xe. It's a noble gas, and its atoms contain 54 protons, 54 electrons, and 77 neutrons. Xenon was discovered by William Ramsay and Maurice Travers in 1898 and is named after xenos, the Greek word for stranger. It's used in lighting for photography, lasers, and cinema projectors.
Element number 55 is cesium, and its symbol is Cs. It's an alkali metal, and its atoms contain 55 protons, 55 electrons, and 78 neutrons. Cesium was discovered by Robert Bunsen and Gustav Kirchhoff in 1860 and is named after Caesius, the Latin for sky blue. In its radioactive state, cesium is used to measure very precise amounts of time and is even responsible for defining how long 1 second is.
Element number 56 is barium, and its symbol is Ba. It's an alkaline earth metal, and its atoms contain 56 protons, 56 electrons, and 81 neutrons. Barium was discovered by Carl Wilhelm Scheele in 1772 and is named after varis, the Greek word for heavy. Combining barium with sulfur and oxygen creates a compound that appears opaque in X-ray scans, making it very useful to visualize the digestive system for medical purposes.
Element number 57 is lanthanum, and its symbol is La. It's a rare earth metal, and its atoms contain 57 protons, 57 electrons, and 82 neutrons. Lanthanum was discovered by Carl Gustav Mosander in 1838 and is named after lanthanin, the Greek for to lie hidden. It's used in batteries for hybrid electric vehicles and is also added to glass found in some camera lenses to improve image clarity.
Element 58 is cerium, and its symbol is Ce. It's a rare earth metal, and its atoms contain 58 protons, 58 electrons, and 82 neutrons. Cerium was discovered by Martin Heinrich Klaproth, Jens Jakob Berzelius, and Wilhelm Hiesinger in 1803 and is named after the dwarf planet Ceres. Because it's the only element apart from iron that makes sparks when struck, cerium is used in lighters.
Element number 59 is praseodymium, and its symbol is Pr. It's a rare earth metal, and its atoms contain 59 protons, 59 electrons, and 82 neutrons. Praseodymium was discovered by Karl Auer von Welsbach in 1885 and is named after Prasios Didymos, the Greek for green twin. Because it filters out yellow light and infrared heat radiation, praseodymium is used to make protective goggles for welders and glassblowers.
Element number 60 is neodymium, and its symbol is Nd. It's a rare earth metal and its atoms contain 60 protons, 60 electrons and 84 neutrons. Neodymium was discovered by Karl Auer von Welsbach in 1885 and is named after Neos Didymos, the Greek for new twin. It can be used to create the strongest known magnets that can lift 1,000 times their own weight and are used in microphones, speakers and headphones.
Element number 61 is promethium, and its symbol is Pm. It's a rare earth metal, and its atoms contain 61 protons, 61 electrons, and 84 neutrons. Promethium was discovered by Charles D. Coriel, Jacob A. Marinsky, and Lawrence E. Glendenning in 1945, and is named after Prometheus, a titan from ancient Greek mythology. It's mostly used for research purposes, and it's estimated that there's only around 600 grams of promethium on Earth.
Element number 62 is samarium and its symbol is Sm. It's a rare earth metal and its atoms contain 62 protons, 62 electrons and 88 neutrons. Samarium was discovered by Paul-Émile Lecoq de Beaubaudron in 1879 and is named after the mineral samarskite in which it was found. In its radioactive form, samarium is used to kill cancer cells but is also used to determine the age of rocks and meteorites.
Element number 63 is europium, and its symbol is Eu. It's a rare earth metal, and its atoms contain 63 protons, 63 electrons, and 89 neutrons. Europium was discovered by Eugène Anatole Damascene in 1896. Because it glows red under UV light, europium is used to print banknotes used in Europe, the continent it's named after.
Element number 64 is gadolinium and its symbol is Gd. It's a rare earth metal and its atoms contain 64 protons, 64 electrons and 93 neutrons. Gadolinium was discovered by Jean-Charles Galissard de Marignac in 1880 and is named after Johann Gadolin, who discovered the element yttrium. Because it's very good at absorbing neutrons, gadolinium is used in the cores of nuclear reactors.
Element number 65 is terbium, and its symbol is Tb. It's a rare earth metal, and its atoms contain 65 protons, 65 electrons, and 94 neutrons. Terbium was discovered by Carl Gustaf Mosander in 1843, and is named after Ytterby, the village in Sweden where it was discovered. When it's mixed with other metals, terbium is used in sensors, motors, and sonar.
Element number 66 is dysprosium and its symbol is Dy. It's a rare earth metal and its atoms contain 66 protons, 66 electrons and 97 neutrons. Dysprosium was discovered by Paul-Émile Lecoq de Beaubaudron in 1886 and its name comes from dysprositos, the Greek word meaning hard to get at. Because it's very magnetic, dysprosium is used in data storage devices like CDs and hard disk drives.
Element number 67 is holmium, and its symbol is Ho. It's a rare earth metal, and its atoms contain 67 protons, 67 electrons, and 98 neutrons. Holmium was discovered by Jacques-Louis Sauret and Marc de la Fontaine in 1878, and is named after Ulmia, the Latin name for Stockholm. It has the highest magnetic strength of any element, and is used in lasers for medical and dental purposes.
Element number 68 is erbium and its symbol is Er. It's a rare earth metal and its atoms contain 68 protons, 68 electrons and 99 neutrons. Erbium was discovered by Carl Gustaf Mosander in 1843 and is named after Ytterby, the village in Sweden where it was discovered. It's used to amplify broadband signals carried by fibre optic cables, making internet connections stronger.
Element number 69 is thulium, and its symbol is Tm. It's a rare earth metal, and its atoms contain 69 protons, 69 electrons, and 100 neutrons. Thulium was discovered by Père Théodore Clever in 1879, and is named after Thule, an ancient Roman and Greek name for a mythical country in the far north. It's used in portable X-ray devices for medical and dental purposes, and to visualise hard-to-reach mechanical and electronic components.
Element number 70 is ytterbium and its symbol is Yb. It's a rare earth metal and its atoms contain 70 protons, 70 electrons and 103 neutrons. Ytterbium was discovered by Jean-Charles Galissard de Marignac in 1878 and is named after Ytterby, the village in Sweden where it was discovered. Because it becomes more electrically resistant when under a lot of force, ytterbium is used to monitor ground movements from earthquakes and explosions.
Element number 71 is lutetium, and its symbol is Lu. It's a rare earth metal, and its atoms contain 71 protons, 71 electrons, and 104 neutrons. Lutetium was discovered by Karl Auer von Welsbach and Georges Urbain in 1906, and is named after Lutetia, the Latin word for Paris. It's mostly used for research purposes because it's one of the rarest and most expensive of the rare earth metals, costing around $10,000 per kilogram.
Element number 72 is hafnium, and its symbol is HF. It's a transition metal, and its atoms contain 72 protons, 72 electrons, and 106 neutrons. Hafnium was discovered by Dirk Coster and George de Hevesy in 1922 and is named after Hafnia, the Latin word for Copenhagen, where it was discovered. When it's mixed with other metals, hafnium is used for liquid rocket thruster nozzles, like those found on moon landing crafts.
Element number 73 is tantalum, and its symbol is Ta. It's a transition metal, and its atoms contain 73 protons, 73 electrons, and 108 neutrons. Tantalum was discovered by Anders Gustaf Eckebye in 1802, and is named after Tantalus, a character from ancient Greek mythology. Because it can be extremely strong when mixed with other metals, tantalum has been used for turbine blades, rocket nozzles, and nose caps for supersonic aircraft.
Element number 74 is tungsten, and its symbol is W. It's a transition metal, and its atoms contain 74 protons, 74 electrons, and 110 neutrons. Tungsten was discovered by Juan José Eluyer and Fausto Eluyer in 1783. Its name comes from the Swedish and Dutch word for heavy stone, and its symbol comes from Wolfram, the German word for tungsten. Because it has the highest melting point of any element, tungsten is often used in high-temperature situations such as welding and furnaces.
Element number 75 is rhenium, and its symbol is Re. It's a transition metal, and its atoms contain 75 protons, 75 electrons, and 111 neutrons. Rhenium was discovered by Walter Noddack, Ida Noddack, and Otto Berg in 1925. And its name comes from the River Rhine in Germany. In its radioactive form, rhenium is used to treat skin, liver, and pancreatic cancer.
Element number 76 is osmium, and its symbol is Os. It's a transition metal, and its atoms contain 76 protons, 76 electrons, and 114 neutrons. Osmium was discovered by Smithson Tennant in 1803, and it is named after osmi, the Greek word for smell, because a form of osmium can smell very foul. It's one of the densest elements and is often mixed with other metals to make electrical contacts and the tips of fountain pen nibs.
Element number 77 is iridium, and its symbol is Ir. It's a transition metal, and its atoms contain 77 protons, 77 electrons, and 115 neutrons. Iridium was discovered by Smithson Tennant in 1803, and its name comes from iris, the Latin word for rainbow, because many of its salts are strongly coloured. When mixed with platinum, it's used to define the exact measurement of both a metre and a kilogram.
Element number 78 is platinum, and its symbol is Pt. It's a transition metal, and its atoms contain 78 protons, 78 electrons, and 117 neutrons. Platinum was discovered by Antonio de Ulloa in 1735, although it had already been known to many peoples for millennia. Platinum is named after platina, the Spanish word meaning little silver. It's highly valuable and is used in one of the thermometers that defines the Kelvin and Celsius temperature scales.
Element number 79 is gold, and its symbol is Au. It's a transition metal, and its atoms contain 79 protons, 79 electrons, and 118 neutrons. Gold was discovered in the Middle East before 6000 BCE, and its symbol comes from aurum, the Latin word for gold, which means shining dawn. It's a precious metal that has been used for coins, jewellery, and other arts for millennia.
Element number 80 is mercury, and its symbol is Hg. It's a transition metal, and its atoms contain 80 protons, 80 electrons, and 121 neutrons. Mercury was discovered by the ancient Egyptians before 1500 BCE, and it's named after the Greek god of speed. Mercury's symbol comes from hydrargyrum, the Latin word meaning water silver. It's used in many things like thermometers, but mercury's use has decreased over the years as it's extremely toxic.
Element number 81 is thallium, and its symbol is Tl. It's a basic metal, and its atoms contain 81 protons, 81 electrons, and 123 neutrons. Thallium was discovered by William Crookes in 1861, and is named after thalos, the Greek word meaning green twig. It's used in lots of ways, but underwater, thallium is used in lamps and seawater batteries.
Element number 82 is lead, and its symbol is Pb. It's a basic metal, and its atoms contain 82 protons, 82 electrons, and 125 neutrons. Lead was discovered in the Middle East in around 7000 BCE, and its symbol comes from plumbum, the Latin name for lead. Before being banned for its toxicity, lead had been used to make things like pipes for millennia, which is where we get the word plumber from. Nowadays, it's still used extensively as a shielding for radiation.
Element number 83 is bismuth, and its symbol is Bi. It's a basic metal, and its atoms contain 83 protons, 83 electrons, and 126 neutrons. Bismuth was discovered by Arabic alchemists before 1000 CE, and its name comes from Bismut, the German word meaning white mass. It's been used for centuries in medicine to treat things like digestive complaints and eye infections.
Element number 84 is polonium, and its symbol is Po. It's a semi-metal, and its atoms contain 84 protons, 84 electrons, and 125 neutrons. Polonium was discovered by Marie Curie and Pierre Curie in 1898, and it's named after Poland, the Curie's country of origin. Because alpha radiation can make a single gram of it reach 500 degrees Celsius, polonium is useful as a source of power for space equipment.
Element number 85 is astatine, and its symbol is At. It's a halogen, and its atoms contain 85 protons, 85 electrons, and 125 neutrons. Astatine was discovered by Dale R. Corson, Kenneth Ross Mackenzie, and Emilio Segre in 1940. It's named after astatos, the Greek word meaning unstable. Astatine is the rarest naturally occurring element, and in total, the Earth is estimated to only contain 28 grams of it.
Element number 86 is radon, and its symbol is Rn. It's a noble gas, and its atoms contain 86 protons, 86 electrons, and 136 neutrons. Radon was discovered by Ernest Rutherford and Robert B. Owens in 1899, and its name is a shortening of the term radium emanation. Because it has a half-life of only around 4 days, detecting radon in its radioactive form means that the surrounding area has been recently disturbed, and so it's being studied as a way to predict earthquakes.
Element number 87 is francium, and its symbol is Fr. It's an alkali metal, and its atoms contain 87 protons, 87 electrons, and 136 neutrons. Francium was discovered by Marguerite Perret in 1939, and is named after France, the country it was discovered in. Because it has a half-life of only 22 minutes, francium is only ever used for research purposes.
Element number 88 is radium, and its symbol is Ra. It's an alkaline earth metal, and its atoms contain 88 protons, 88 electrons, and 138 neutrons. Radium was discovered by Marie Curie and Pierre Curie in 1898, and its name comes from its radioactive nature. In the past, it was used to make glow-in-the-dark paints for things like watches, aircraft switches, and instrument dials, but it was later found to be very toxic, leading to the deaths of many people, including Marie Curie herself.
Element number 89 is actinium, and its symbol is Ac. It's a rare earth metal, and its atoms contain 89 protons, 89 electrons, and 138 neutrons. Actinium was discovered by Friedrich Oskar Giesel in 1902, and it's named after actinos, the Greek word for beam of light. It's mostly used for research purposes, and is currently being studied for use in treating cancer.
Element number 90 is thorium, and its symbol is Th. It's a rare earth metal, and its atoms contain 90 protons, 90 electrons, and 142 neutrons. Thorium was discovered by Jöns Jakob Berzelius in 1829 and is named after Thor, the Norse god of thunder. Its radioactive nature can cause it to be a health risk in certain forms, but it can be used safely in things like glass lenses for cameras and scientific equipment.
Element number 91 is protactinium, and its symbol is Pa. It's a rare earth metal, and its atoms contain 91 protons, 91 electrons, and 140 neutrons. Protactinium was discovered by Kazimierz Fajans and Oswald Helmut Göring in 1913, and its name means before actinium because it produces actinium through radioactive decay. Because it's both very rare and very dangerous, protactinium is only used for research purposes.
Element number 92 is uranium, and its symbol is U. It's a rare earth metal, and its atoms contain 92 protons, 92 electrons, and 146 neutrons. Uranium was discovered by Martin Heinrich Klaproth in 1789 and is named after the planet Uranus. It's mainly used as a fuel source in nuclear power plants, and a single kilogram of uranium can produce as much energy as 1,500 tons of coal.
Element number 93 is neptunium, and its symbol is Np. It's a rare earth metal, and its atoms contain 93 protons, 93 electrons, and 144 neutrons. Neptunium was discovered by Edwin Macmillan and Philip H. Abelson in 1940, and is named after the planet Neptune. It can be turned into a form of plutonium, which can be used by machines that provide power for spacecraft.
Element number 94 is plutonium, and its symbol is Pu. It's a rare earth metal, and its atoms contain 94 protons, 94 electrons, and 150 neutrons. Plutonium was discovered by Glenn T. Seaborg, Arthur Weil, Joseph W. Kennedy, and Edwin Macmillan in around 1941, and is named after the dwarf planet Pluto. The detonation of a kilogram of plutonium produces an explosion equivalent to over 10,000 tons of chemical explosive and is still used in nuclear weapons today. Plutonium is the last element that occurs naturally on Earth. From this point onwards, all the remaining elements had to be artificially created or synthesized, so they have very limited use outside of research.
Element number 95 is americium, and its symbol is Am. It's a rare earth metal, and its atoms contain 95 protons, 95 electrons, and 148 neutrons. Americium was synthesized by Glenn T. Seaborg, Ralph A. James, Leon O. Morgan, and Albert Ghiorso in 1944, and was named after the Americas. Although it's radioactive, americium is much less harmful than radium, and is used in the most common type of household smoke detectors.
Element number 96 is curium, and its symbol is Cm. It's a rare earth metal, and its atoms contain 96 protons, 96 electrons, and 151 neutrons. Curium was synthesized by Glenn T. Seaborg, Ralph A. James, and Albert Ghiorso in 1944, and is named after Marie and Pierre Curie. It's used in X-ray instruments on board various spacecraft to analyze rocks on the surface of the planet Mars.
Element number 97 is berkelium, and its symbol is Bk. It's a rare earth metal, and its atoms contain 97 protons, 97 electrons, and 150 neutrons. Berkelium was synthesized at the Lawrence Berkeley National Laboratory in 1949, and is named after the University of California, Berkeley. Because it's so rare, berkelium is currently only used for research purposes.
Element number 98 is californium, and its symbol is Cf. It's a rare earth metal, and its atoms contain 98 protons, 98 electrons, and 153 neutrons. Californium was synthesized at the Lawrence Berkeley National Laboratory in 1950 and is named after California, where it was discovered. It's used to identify various things like gold and silver ores, water and oil layers in oil wells, and problems with aeroplanes.
Element number 99 is Einsteinium, and its symbol is Es. It's a rare earth metal, and its atoms contain 99 protons, 99 electrons, and 153 neutrons. Einsteinium was discovered by the Lawrence Berkeley National Laboratory in the debris of a nuclear bomb test in 1952. It's named after Albert Einstein, one of the most famous people in the history of science.
Element 100 is fermium, and its symbol is Fm. It's a rare earth metal, and its atoms contain 100 protons, 100 electrons, and 157 neutrons. Fermium was discovered by the Lawrence Berkeley National Laboratory in 1952 in the debris of a nuclear bomb test, and its namesake Enrico Fermi created the world's first nuclear reactor.
Element number 101 is mendelevium, and its symbol is Md. It's a rare earth metal, and its atoms contain 101 protons, 101 electrons, and 157 neutrons. Mendelevium was synthesized at the Lawrence Berkeley National Laboratory in 1955 and is named after Dmitry Mendeleev, who pioneered the periodic table. Mendelevium is currently only used for research purposes.
Element 102 is nobelium, and its symbol is No. It's a rare earth metal, and its atoms contain 102 protons, 102 electrons, and 157 neutrons. Nobelium was synthesized at the Joint Institute for Nuclear Research in 1966 and is named after Alfred Nobel, who founded the Nobel Prize. Nobelium is currently only used for research purposes.
Element number 103 is lawrencium, and its symbol is Lr. It's a rare earth metal, and its atoms contain 103 protons, 103 electrons, and 159 neutrons. Lawrencium was synthesized at the Lawrence Berkeley National Laboratory in 1961 and the Joint Institute for Nuclear Research in 1971. It's named after Ernest Lawrence, an American nuclear scientist who invented the cyclotron, which is used to synthesize elements.
Element 104 is rutherfordium, and its symbol is Rf. It's a transition metal, and its atoms contain 104 protons, 104 electrons, and 163 neutrons. Rutherfordium was synthesized by the Joint Institute for Nuclear Research in 1964 and the Lawrence Berkeley National Laboratory in 1969. It's named after Ernest Rutherford, a British physicist who, among other things, discovered the proton.
Element number 105 is dubnium, and its symbol is Db. It's a transition metal, and its atoms contain 105 protons, 105 electrons, and 165 neutrons. Dubnium was synthesized at both Lawrence Berkeley National Laboratory and the Joint Institute for Nuclear Research in 1970. It's named after Dubna, the town in Russia where the JINR is located. Only a few atoms of dubnium have ever been created.
Element 106 is seaborgium, and its symbol is Sg. It's a transition metal, and its atoms contain 106 protons, 106 electrons, and 163 neutrons. Seaborgium was synthesized at the Lawrence Berkeley National Laboratory in 1974. It's named after Glenn T. Seaborg, an American chemist who was involved in the discovery of 10 elements, including plutonium, curium, and einsteinium.
Element number 107 is bohrium, and its symbol is Bh. It's a transition metal, and its atoms contain 107 protons, 107 electrons, and 163 neutrons. Bohrium was synthesized at the GSI Research Centre in 1981. It's named after Niels Bohr, a Danish physicist who won the Nobel Prize in 1922 for his work on the structure of atoms and quantum theory.
Element 108 is hassium, and its symbol is Hs. It's a transition metal, and its atoms contain 108 protons, 108 electrons, and 162 neutrons. Hassium was synthesized at the GSI Research Center in 1984 and is named after Hesse, the state in Germany where the GSI is located. Hassium is currently only used for research purposes.
Element number 109 is meitnerium, and its symbol is Mt. It's a transition metal, and its atoms contain 109 protons, 109 electrons, and 169 neutrons. Meitnerium was synthesized at the GSI Research Center in 1982, and is named after Lise Meitner, an Austrian-Swedish physicist who helped discover the element protactinium.
Element 110 is Darmstadtium, and its symbol is Ds. It's a transition metal and its atoms contain 110 protons, 110 electrons, and 171 neutrons. Darmstadtium was synthesized at the GSI Research Center in 1994 and is named after Darmstadt, the city in Germany where the GSI is located. Darmstadtium is currently only used for research purposes.
Element number 111 is roentgenium, and its symbol is Rg. It's a transition metal, and its atoms contain 111 protons, 111 electrons, and 170 neutrons. Roentgenium was synthesized at the GSI Research Center in 1994. It's named after Wilhelm Röntgen, a German physicist who accidentally discovered X-rays in 1895.
Element 112 is copernicium, and its symbol is Cn. It's a transition metal, and its atoms contain 112 protons, 112 electrons, and 173 neutrons. Copernicium was synthesized at the GSI Research Center in 1996. It's named after Nicolaus Copernicus, a Renaissance polymath who devised a model of the universe with the sun at the center.
Element number 113 is nihonium, and its symbol is NH. It's a basic metal, and its atoms contain 113 protons, 113 electrons, and 173 neutrons. Nihonium was synthesized at the Riken Research Institute in 2004. It's named after Nihon, a Japanese word for Japan, where Riken is located. Nihonium is currently only used for research purposes.
Element 114 is flerovium, and its symbol is Fl. It's a basic metal, and its atoms contain 114 protons, 114 electrons, and 175 neutrons. Flerovium was synthesized at both the Joint Institute for Nuclear Research and the Lawrence Livermore National Laboratory in 1999. It's named after Georgy Flerov, a Russian nuclear physicist who founded the JINR. Flerovium is currently only used for research purposes.
Element number 115 is moscovium, and its symbol is Mc. It's a basic metal, and its atoms contain 115 protons, 115 electrons, and 174 neutrons. Moscovium was synthesized at both the Joint Institute for Nuclear Research and Lawrence Livermore National Laboratory in 2003. It's named after Moscow, the city in Russia where the JINR is located. Moscovium is currently only used for research purposes.
Element 116 is livermorium, and its symbol is Lv. It's a basic metal, and its atoms contain 116 protons, 116 electrons, and 177 neutrons. Livermorium was synthesized at both the Joint Institute for Nuclear Research and Lawrence Livermore National Laboratory in 2000. It's named after Livermore, the city in California where the LLNL is located. Livermorium is currently only used for research purposes.
Element number 117 is tennessine, and its symbol is Ts. It's a halogen, and its atoms contain 117 protons, 117 electrons, and 176 neutrons. Tennessine was synthesized at the Joint Institute for Nuclear Research, Lawrence Livermore National Laboratory, Vanderbilt University, and Oak Ridge National Laboratory in 2009. It's named after Tennessee, the US state where both Vanderbilt University and the ORNL are located. Tennessine is currently only used for research purposes.
Element 118 is oganesson, and its symbol is Og. It's a noble gas, and its atoms contain 118 protons, 118 electrons, and 176 neutrons. Oganesson was synthesized at both the Joint Institute for Nuclear Research and Lawrence Livermore National Laboratory in 2002, and is named after Yuri Oganessian, who was heavily involved in its discovery and the discovery of many other elements. Oganesson is the heaviest element known so far and is currently only used for research purposes.
And that, as of 2021, is every single element.
But who knows? This could just be a tiny section of an infinite list of elements with even more dazzling properties.
If you haven't already, make sure to watch the periodic table video to learn the secrets of its layout and how many of the elements were predicted long before they were discovered. If you like this video, make sure to give it a thumbs up. Subscribe to learn more science, English and maths with Will, and let me know what you want to learn next by commenting below or emailing info@learnwithwill.co.uk.